Carl Sagan could not have predicted was trying to tell us back then.
Ashton Forbes, you know, that super jacked guy.
Malaysian 370, contact Ho Chi Minh 120.9. Good night. Good night, Malaysian 370.
Breaking news tonight, a Malaysia Airlines flight with 239 people on board, including 4 Americans, has gone missing.
Even as these grainy satellite images released today by the Chinese government.
Again, the Malaysian flight too was one shot at China saying knock it off.
Why shoot it down though if it's not hostile?
Our technologies permit us to manipulate time and space.
Why the Americans would?
They leave distance annihilated.
This country is very powerful. Far more powerful than people understand. We have weaponry that nobody has any idea what it is, and it is the most powerful weapons in the world. Not even close.
I remembered the line from the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should be his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds." I suppose we all thought that, one way or another.
Oh, it's physics time, chat. It is physics time. Guys, people are criticizing that I talk to you all like this. You know what I have to say to the haters? Too bad, chat. I love talking like this. Number one, it amuses me, and that's the only thing that matters. By the way, guys, how's my shirt look today? I hope you guys are having a great night. You know what? I'm not feeling it. This is for you, Eddie. Bow wow, chicka bow wow. Here you go, ladies. My OnlyFans has begun officially right now. Would you look at that, chat? Oh, man. Stolen valor. Stolen valor, they say. You know what? I dare you. I dare you to call me out on stolen valor. I know a guy. Very important in the VPU too. He's kind of a big deal. He's given me the pass, as it turns out. Woo! The drip is on point, chat. Woo! Okay, we are ready for some science. First things first, we have some things that we need to discuss. Lindsey Graham has passed away, poisoned by our enemies, chat. We already figured out who the cause was. It was obvious from the beginning. Putin did this. Putin's responsible, obviously. I mean, we don't have to investigate or get any facts. We know that Vladimir Putin did this. Putin hates America. He hates our freedoms. Lindsey Graham loved our freedoms and loved destroying everybody that doesn't love our freedoms. So rest in peace to the war goat. Let him be remembered fondly. And we will get vengeance on our enemies for taking him out. Let's get serious, though. Actually, no, one more thing. 2 more things. General McCaslin. Oh, yeah. Also, the Jurassic Park guy died, chat. Sam Neill, the GOAT. They're just dying left and right. We're getting older. Time is moving on. We're getting older. We still don't have 0 point energy. We don't even have basic fusion, let alone aneutronic fusion, which they've already been hiding. They've already got teleportation. We're not even close to it. So we need these live streams to catch up to them, to steal back the knowledge which they've been accelerating in the shadows away from us. That's the reason why tonight I want to highlight a few members of the community, either tangentially, directly. Turns out at least one is directly a member of our community. But before we get to that, General McCaslin is still missing for over 100 days. Oh, we're blurry. Okay, 1 second, guys. Still blurry. Chat, I got to work on that. Okay, my whole thing was blurry with the shirt. You are kidding me, chat. The whole shirt thing was blurry. Rest in peace, my stream. We're starting over. Just kidding. Okay, General McCaslin missing for over 100 days. The only one fighting for the truth is ZPE disclosure. That's the only person I see out there fighting for the truth about General McCaslin. Do we really believe that the feds have no idea where General McCaslin is? Of course they know. Of course they know. Why are they not telling us? This is an actual conspiracy that the conspirators should be looking into, and every day that goes by is a travesty because he is still gone and no one knows, especially his wife. He's with the tall whites, indeed. Proves this is a live stream. Some people don't believe. One more thing now. I found out right before this live stream that one of the people we were about to talk about is a member of this community. And actually, this is nothing could give me higher praise than finding out that the people that are presenting on APEC are actually members of this community that follow along, that enjoy the content, that in some cases even look up to me out of all people. So I hope he doesn't mind, but I got a ping from Gabriel Diaz right before this on Twitter, and I was already ready, prepared to show off some of his clips because I thought he did a really good job on APEC. And then I find out, oh, he was like looking up to me and looking for my approval. And I just thought, wow, we have really made it in the ZPE community by pushing more and more people towards this content, inspiring them to investigate and do their own science and their own theories based on it. That was my goal from the very beginning. And now we're watching it play out. It's like watching your kid go off to college. I couldn't be happier. So I just wanted to let you guys know that. Now, before we get into this, and this is related to Gabriel's presentation, is boundary condition changes. This is the felony physics topic of tonight. Boundary condition changes. The Casimir effect. What I try to teach people is that the Casimir effect is itself not the mechanism by which we're going to make a warp drive. Two metal plates that are coming together is never going to create a warp drive for us. But we can learn something about physics from that effect. And what we learn from physics is that space is not empty. Space is not an empty vacuum. The thing that Sabine Hassenfelder needs to get through her thick skull at the moment. She's a hard one to crack, it turns out. And if space is not empty, that means that in theory, what's really happening is that space is pushing on us all the time from every direction on every atom. This means that, like, imagine a balloon. Imagine I have a balloon and I push on that balloon. What happens if I let go? Whoa, it shoots back out. Pew! That's negative energy. Does that make sense? What we're trying to accomplish from a warp drive, wormhole, even EM drive, we're pushing back on the medium, but not quite. We're pushing on that medium and we're letting it slingshot us back. But we're doing that, and when we're doing that, we're breaking the light barrier. Much analogous to breaking the sound barrier in air. That's why the equations look so similar. So the felony physics topic tonight, the boundary conditions, what we learn from the Casimir effect is that these plates, if we move them relativistically, light gets trapped, bounces off the mirrors, bounces off of them, gets trapped, and then boom, pops into existence. It's a real effect. You came for physics, and here it is. First paper of the night. Probably the only paper, to be honest, but it's an important one. Observation of the dynamic Casimir effect in a superconducting circuit. This is not theoretical. This is very important. This is experimentally proven. One of the most surprising predictions of modern quantum theory, all of this comes from quantum field theory, is that the vacuum of space is not empty. That's the very first sentence in this paper. This is 2011, by the way. In fact, quantum theory predicts that it teems with virtual particles flitting in and out of existence. This is the 0-point energy. This is the 0-point energy. Although initially a curiosity, it was quickly realized that these vacuum fluctuations had measurable consequences. For instance, producing the Lamb shift of the electron. This type of renormalization due to vacuum fluctuations is now central to our understanding of nature. However, these effects provide indirect evidence for the existence of vacuum fluctuations. From early on, it was discussed whether or not it may be possible to more directly observe these virtual particles. 40 years ago, it was suggested a mirror undergoing relativistic motion could convert virtual photons into directly observable photons. This phenomenon, later termed the dynamic Casimir effect, had not been previously demonstrated. This is the first time this effect was experimentally demonstrated. Here we observe the dynamic Casimir effect in a superconducting circuit consisting of a coplanar transmission line within a tunable electric length. The rate of change of the electrical length can be made very fast. So they've made an equivalent analog of the mirrors moving back and forth. In addition to the observation or observing creation of real photons, they also detect a two-mode squeezing in the emitted radiation, which is a signature of the quantum character of the generation process. Go ahead, Sabine. Go ahead and debunk the dynamic Casimir effect. So, the key element is taking the same Casimir effect and now applying a time-varying condition. You may say, Ashton, what the hell does that mean? Good question. Very good question. Well, the answer is this, or this, I suppose. You have your mirror is moving, or this, spinning. It means that from your perspective, let's say you're on an airplane and there's some orbs spinning around you and they're spinning around your plane vertically. You're watching the orbs spin around, and from your perspective, it looks like they're spinning around in a circle around you. That's a time-varying condition. That orb moves from that place to that place to that place, and it's all perfectly geometric around you. This is the secret to probably nuclear weapons as well. I don't know that for a fact, so the government can't come after me. I'm only speculating. But time-varying boundary condition, and it has been proven that when they push this to relativistic speeds, very high rates of speed, that light comes out of nowhere. This is also the most logical explanation for sonoluminescence. I went hard at people at this. Why? Because where is the light coming from in this effect right here? I mean, where is the light actually coming from? This is just sound waves in water. Sound waves in water causing a cavitation bubble, and everybody agrees that it's the cavitation bubble which causes the light to come out. But what does that mean? You just blew a bubble in there with some sound waves, and then it collapsed so quickly. It collapsed so quickly that it produced light. I mean, just from a classic physics perspective, that doesn't make any sense to me. It feels like the cavitation shouldn't be able to collapse so quickly that light appears out of nowhere under a classic physics perspective. And it turns out, I think that's true. Now, where did I go to find this most recent information? Practical conversion of 0-point energy. Thomas Vallone, PhD, by the way. He did get his PhD, knows his shit. And he was a patent examiner, too. And right here on page 21, it says ZPE and sonoluminescence. So let's listen to the actual arguments, the facts, the details, the scientific papers. Those science people be bitches sometimes. It's factual. Scientists at UCLA have recently measured the length of time that sonoluminescence flashes persist. How long that flash persists. It was very quick. Barber discovered that they only exist for 50 picoseconds or shorter, which is too brief for the light to be produced by some atomic process. So it can't be some atomic nuclear process at place there. Atomic processes, in comparison, emit light for at least several tenths of a second. So the light should have been flat, should have persisted for longer. And this is a direct quote, to the best of our resolution, which has only established upper bounds, the light flashes less than 50 picoseconds in duration and occurs within 0.5 nanoseconds of the minimum bubble radius. The sonoluminescence flash width is thus 100 times shorter than the shortest visible lifetime of an excited state of a hydrogen atom. Wow. Wow, chat. The other thing I want to point out here is Julian Schwinger, as in the guy that won the Nobel Prize for quantum electrodynamics, for developing quantum electrodynamics with Richard Feynman in 1965. That Julian Schwinger. Schwinger proposed a physical mechanism for sonoluminescence in terms of photon production due to changes in the property of the vacuum arising from a collapsing dielectric bubble. Well, chat. Well. Julian Schwinger believed that it was a phenomenon related to the vacuum, as well as cold fusion. Turns out all of our goats were on our side and still on our side spiritually. Let's get to the content because we got more to go through here tonight. First off, now that we understand that boundary conditions are important, let's take one more look at the MH370 videos. Now that we've learned a little bit, we're a little smarter now than the average bear when it comes to physics. Now, when we look at this, we don't see video games or pictures of clouds. Jesus Christ. This one rules out the pictures of clouds, and the other one rules out the video game effects. But anyway, now that we look at these orbs spinning around the plane, at first we can tell they've got to be locking in. They're trying to figure out where do they have to go to get into the right position to mess around with the boundary conditions. And they've already gotten to the correct radius from the plane. And now here we can't see because it happens while it's off screen. But the orbs have locked in vertically now. They've locked in vertically. And this is the part where I'm saying, if you're on the airplane, the position of the orb is changing, creating the time-varying boundary condition. This is basically twisting, manipulating space-time. And this is going to be important from both of the clips and presentations that we're going to be watching here today. Now, I use this as an example because this is the best possible example. And these plasma orbs are acting as mirrors, moving mirrors. You would say, Ashton, how is that possible? And at first, I was surprised as well. But it turns out with just 3 objects like this, you don't need to have a perfectly flat mirror. In fact, because you want a time-varying condition, You actually want it to be like just an orb like this, or let's say a nacelle, as Sonny White would put it. So we have our time-varying plasma orb condition, and then watch what happens at the end. Did you see that? They converge. Let's slow it down. So I think we're still accurate in terms of these are little fusion reactors, but they're using them in the high beta condition to create these time-varying space-time condition. And look, they pulled in. They pulled in. They pulled in just like the dynamic Casimir effect. They had set the cylinder they had created from spinning around the plane. They created an invisible cylinder. And then at the last moment, they pull the boundary conditions in. And then what do we see happen? We see an implosion. We see an implosion occur here. Watch this. It expands out and then it sucks back in. Well, dynamic Casimir effect. But the thing that gives me pause, I want to present both sides of this. Even though they pull in really quickly, like we can barely see it. We can barely see it when they pull in full speed. I still think, damn, they only have to pull in that fast and they can warp space-time. In my mind, I would have thought, oh, it needs to be like moving super fast, like to the point where the camera can't even catch it. But the camera caught it in like 4 frames. That's the only thing that gives me pause, but I have a feeling I'm going to be totally wrong about that, and that's not a big deal at all. But that's what's crazy, because it reminds me of what Salvatore Pais said. This physics is easy. It's not hard. It's easy, and that's what makes it scary. That's what makes it dangerous, because when people figure it out, it's going to be impossible to stop people from making super powerful weapons, because they don't need like things moving at the speed of light in order to warp space-time. They just have to figure out the geometry and the resonance, and then boom. Interesting. Okay. Hopefully is our video better, by the way? I didn't check. Didn't care. Didn't check, didn't care. Okay, let's start with number 1. We're going to go to your boy, Gabriel. I'm going to do these in backwards order, I think. No, we're not. Where's the clip? Here it is. I think I have it like ready to go. Yeah. We're not going to play his whole presentation. These guys we're just going to spotlight. But Gabriel's presentation is essentially about using the polarizable vacuum and using these changing boundary conditions to do work. Generically, I think. He probably has ideas on how to do it to produce energy and propulsion. But that goes straight back to what David Froning said. Is that if you understand how this works, now we're talking about a whole new avenue of physics, right? New ways of energy for producing energy. Fusion, ZPE is assisted fusion, or directly pulling energy from the 0-point energy. Or, doing like what we did with what the one guy was doing with water, Stanley Meyer, which is splitting molecules at cheaper energy costs than what we currently think is possible. So it opens up these all new avenues. Here we go. Shout out to Alternate Propulsion Conference, 7-Eleven, guys. Check them out. Alt Propulsion, they could use a lot more followers and more people checking their stuff out. So check their stuff out here. Boundary Condition Vacuum Interaction Systems. Oh, he's working with Douglas Miller, too. So shout out to Douglas Miller. Another, supporter of 0-point energy. We need all the ones we can get. First thing that I thought was amazing. This is a great way to start. Where do you start with this if you're explaining? Number 1, you explain space-time is not empty. Best way to explain this is ground state of the hydrogen atom. Thank you, by the way, Mark. I see you. Mark, for following for 3 years. Appreciate you. Ground state of the hydrogen atom. Why? Because that shows us that every atom, every single atom, not just the atoms in me or the atoms in my phone, every single atom is interacting with the 0-point energy. That's a hugely profound thing to understand. So here you go. Here's our boy. Give him some support. Explaining it.
Meaning just how we measure what we're talking about and how we determine what our device is actually doing. And the framework is Douglas's, and the discrimination work near the end is mine. And discrimination being just the job of telling competing explanations apart. Start with some theory first, before I show you the device, or just a general idea.
First impressions, chat. By the way, no bias. This is no bias. I love the graphics. You see his little spinny ball, his little spinny atom going on the right over there? Chat, one of the first things I learned in entrepreneurship class, you get 1 grade improvement just by adding color, just by adding some graphics. You say, Ashton, that's silly. I say, you have vastly underestimated the intelligence of humans if you don't realize that what I'm saying is absolutely true. It's not even a joke. Not even a joke. Great graphics. Keep them coming.
Idea of it, since I can't actually disclose the real design and materials we're using. And I'll start from a simple question some of you are familiar with, which is, why doesn't the electron collapse into the nucleus of the atom? Or where is the electron getting the energy to keep moving around, jittering indefinitely? Or the stability of the atom problem? Well, according to classical physics, the electron should collapse. Right here. An orbiting electron is an accelerating charge, and that charge radiates energy away over time till the orbit decays, and the electron spirals into the nucleus in about 10 trillionths of a second. So classically speaking, atoms shouldn't exist unless something is feeding energy back in. In quantum mechanics, stability is built into the theory.
So he presented it very quickly. So let me just let it sink in. Under a classical view, whether or not you think it's a cloud of electrons or however you perceive the electron, that movement is energy. If you believe in thermodynamics, then either the atoms are perpetual motion machines, which violates thermodynamics, or the atoms must be radiating energy due to the fact there's movement happening, due to the fact they exist. So how are they saying stable? Why are they stable? Why don't they collapse upon themselves? In fact, they should be collapsing upon themselves in less than a second. That's how fast it should be happening. Think about that. So I'm sure you'll hear Quantum Sabine or the other physicists who've been counter-signaling us hard, and they need to try harder. They need to be trying harder, chat. They're not doing a good enough job right now. They're going to say, well, it's totally explainable. They're going to say, this is totally understood by classical physics. And it's not a mystery at all. And you'll be like, okay, we're waiting for the answer. And they'll be like, it's explained. And you'll be like, so are you going to explain it, or are you just going to say that it's explained? Well, they'll say that the Maxwellian Landau corporations totally have figured that out. They always just name drop some shit instead of just, hey, can you just explain it in like a normal way that a normal person can understand? Because I'm looking at something here that doesn't make any sense whatsoever, just written out on paper. And you're telling me I don't have to worry about that? What if that misunderstanding is a foundational misunderstanding of the universe, of physics itself? It doesn't take a rocket scientist to figure out that this means there's an ether of energy all around us. Please continue, sir.
Through Heisenberg's uncertainty principle, confine, right, the electron more tightly, and its momentum spread grows, costing energy. So there is a lowest possible state, the ground state. And the theory guarantees it's stationary, and it works just fine. No problem.
For my dum-dums out there, just look at the graphic. You see the graphic? You see how it spins inward and then it crashes? There you go. That's the problem. You don't need to understand any of the words. That's it. That's the problem. Now, how do you solve that? How do you make sure your thing doesn't crash inward? Pew, pew, pew. We inject more energy. There's something there. The same reason why when we look at the galaxies, How come they spin faster along the edges than we would predict? Oh, look at this. Is it the same as this little guy over here? Interesting.
Problem with that, although it could be a little counterintuitive sometimes. But in stochastic electrodynamics, SED, there is a third answer, and that is balance. In stochastic electrodynamics, there's a real classical field in the background that's present everywhere all the time, and that field gives the atoms their stability. The electron does radiate energy, exactly as classical physics says, but it also absorbs energy continuously from this background field, and then the two rates cancel right here. So Dr. Hal Puthoff in 1987 computed that the balance for the ground state of the hydrogen atom is even. So average power emitted equals average power absorbed. So this third answer gives us a real...
So right there, the ground state, you automatically get a gold star. If you come into your 0-point energy presentation, you start with a ground state of the hydrogen atom, which is, of course, where you start. 1987. That's where you start. Then you realize how Puthoff saying, yes, of course, the electron's radiating energy. It must be. I believe in thermodynamics, chat. Hal Puthoff says, I believe in science. Quantum Sabine Hassenfelder doesn't believe in science, chat. She believes that atoms are perpetual motion machines violating the laws of physics. I believe in science. I believe that the electron atom must be radiating energy, and it must be also absorbing the same amount of energy. It must be absorbing the exact same amount of energy, and it, therefore being in a balance all the time. Oh, wow. That's almost like being your rubber ducky in the bathtub, sitting in the bathtub, just chilling on the top of the ocean, on the top of the water.
Field everywhere all the time. And you just can't feel this field for the same reason you just can't feel the atmospheric pressure pushing your body at every moment, because it just pushes from every direction. It pushes the same from every side.
And that's great to point out, because seriously, we're dealing with very dumb people out here. They're saying, why don't we feel this then? Because we're in an equilibrium. We imagine there's nothing pushing on us, that we're just sitting here, there's nothing pushing on us, and therefore there's no negative energy to be gained. But if something's pushing on every atom of our body all the time, and we relieve that pressure, just like the balloon, pay attention. We imagine that the balloon, there's nothing pushing back on the balloon. That's classic physics. Add in 0-point energy, and we realize every atom is like the balloon, but there's something pushing that balloon, keeping it compressed. And if we remove that 0-point energy that keeps it compressed, suddenly it will just accelerate. The negative energy will pull it apart. This also explains why if you do one of these effects to, let's say, the water molecule, you cause the atoms to just split apart.
But what is this field exactly?
Okay, so, okay, I'm going to let this play.
Well, that is the 0-point field, a real random electromagnetic field that's present everywhere all the time. It's also stochastic, meaning it has random phases. So it averages to 0, but it never really stops fluctuating. The pendulum.
Okay, so we know the 0-point energy field. I'm going to skip past this part. We're going to come back to this in a second, because here's the other clip that I want to play. Also of Gabriel, explaining the polarizable vacuum, because now we say we've got this 0-point energy pushing on us all the time. But what about, how do we counteract that push? I mean, if you've been following me, you kind of already may know, but here's a hint. Hal Puthoff, always Hal Puthoff, and his friends.
Puthoff, and also Barry Setterfield.
According to Puthoff, every time. Guys, this is for Congressman Burleson and all the other people that are being played by Hal Puthoff. These guys are very smart. They're smart enough to make lasers. They're smart enough to make gravity wave beams. They're smart enough to make plasma orbs and fusion. They're smart enough to manipulate space-time. They're definitely smart enough to trick you into thinking that you're the first person to figure it out. They're definitely not smart enough to trick you into thinking you should go try to find out about the aliens. Don't worry about our teleportation technology. And I don't think there's another Hal Puthoff, Yoda of the 0 point energy, like hidden in the black world that nobody knows. It's possible, but it seems extremely unlikely. What you find about these guys is they want to be known. They want people to know what they did, but in some cases they have NDAs and therefore they can't talk about it. But they did some crazy stuff. So here we go. Sorry to interrupt. Gabriel, please enlighten the noobs. Enlighten the noobs on the polarizable vacuum, sir.
According to Puthoff and also Barry Satterfield, physicist from Australia, the properties of the vacuum can be modified or polarized. And here's the picture. When 0 point waves interfere, they form charge pairs, an electron and a positron, positive and negative together. In quantum field theory, these are called virtual particle pairs. In the stochastic electrodynamics reading, they're real pairs, popping in and out of existence, producing real observable effects. They live for a very short time and then annihilate each other. Particle and antiparticle canceling back into the field, so the vacuum stays neutral the whole time. Now,
that right there, holy smokes. Nailed it. What did we just say about the dynamic Casimir effect? He says, oh, classical physics says, hey, there are these virtual particle pairs that are popping into existence, but ignore them. They don't matter. They're just there. I mean, quantum mechanics says they're there, but we're not going to worry about it. Turns out those are supplying 97% of the energy of the atom. Those virtual particles are supplying 97. So would you say they're real? Sounds pretty damn real to me. If they supply 97% of the atom energy of your atoms, that's the most real thing there is. Maybe the only real thing there is. So stochastic electrodynamics, Barry Satterfield, they say that these virtual particles are not virtual at all. They're real. And now we can interact with these real particles that are popping into existence, polarize them. Polarizing them is essentially electrifying them, making it so that they all line up the same way electrically. And if we do this, interact with them in some meaningful way, we can change reality. Let's listen.
How do these pairs set the vacuum's properties? If you apply an electric field, before each pair annihilates, it gets slightly stretched, like you can see here, like a dielectric material. Their responsiveness is epsilon naught, right here. The electric constant, and the pair's response to magnetic fields likewise is mu naught, the magnetic constant. And light is exactly the stuff that travels through this medium. An electric field creates a magnetic field, which creates an electric field, and so on.
Does that remind you? And yes, Planck ether hypothesis. There's many hypotheses that are basically exactly the same as this, which is why fighting over the credit is going to be a meaningless endeavor. If you want to do something related to the physics, the best thing you can do is get ahead of what's going to happen and start investing in and or building the technology before other people and trying not to get killed. That's just what I'm going to say. Yeah, sorry.
Maxwell's equations. So magnetic field, which creates an electric field, and so on.
Oh, yeah. And so remember, Dr. Yu said that the light is the perturbation in the medium. And this is essentially what he's saying is if we have this medium, then maybe light is just a fluctuation in this medium. And that's why we are seeing, when we look at the electromagnetic wave, why it's perpendicular. Why electric field seems to produce a magnetic field, magnetic field seems to produce an electric field. And why they're orthogonal, 90 degrees to one another. This is where Jenny Neilsen is going to take over in a second. Because the next question, the question of the A vector potential, says, what if we add one more orthogonal angle? What if we take the pointing vector, the additional orthogonal angle, and we turn that into something?
Maxwell's equations. So the medium's two constants set the speed of light. From this equation right here, c squared equals 1 over epsilon naught times mu naught.
So what's really happening here, as he's pointing out, is that the medium has the speed of light is equal to c as we know it. The speed of light c is actually just a byproduct of this 0 point energy has permeated everywhere. It's in a balance. It's in a balance, and we don't notice because it's pretty much always in a balance all around us. And this is what's giving us all the physical properties, including the speed of light. So if we were somehow able to manipulate this balance of 0 point energy particles, then this would change the speed of light. This would change the physical properties as we see them. This is what accounts for your UFO stories, for your alien stories, for your UFO technology. It's just using quantum mechanics mixed with general relativity, aka our real reality. Now look at those equations. C squared equals 1 divided by mu epsilon, right? Epsilon, whatever. So permittivity times permeability. The magnetic permeability times the electric permeativity. So what he's saying is it's a medium, it's a dielectric medium. Space-time itself is a medium just like some kind of metal. Some kind of a metal that conducts electricity. We just don't realize it. This is where Jack Sarfati doesn't see the full picture. He thinks of space-time as an empty vacuum. Therefore, he thinks you need a material, a metamaterial, to produce these effects. Now, take that same process and apply it to space-time, and you realize, oh, I want plasma to be my trigger, and I'm going to use it and apply it on space-time to change the permeativity, permeability, change the physical properties of space-time. That's what they're doing with the plane. Okay, let me let this finish.
And so Puthoff developed the polarizable vacuum picture. The vacuum as a medium whose electric and magnetic properties can in principle vary. Along with the stability balance we saw at the hydrogen atom. Satterfield extended it, claiming that the density of those charge pairs is what sets epsilon naught and mu naught. So if you change the pair density, in that picture, you change the vacuum's constants locally.
If you change the pair density, you change the vacuum's constants locally. Well, how do we change the pair density? According to David Froning and Terence Barrett, we create an SU2 conditioned field. They were making toroidal rings that had a teardrop shape in them, a kink in them. And in theory, this is manipulating the amount of the 0 point energy. It's probably exactly producing an A vector potential. Producing an A vector potential in space-time itself. So this is where Jenny Lorraine Neilsen comes into play. And from my understanding of her work, I probably should invite these people on to let them speak for themselves. Okay, whatever, chat. I get it. Don't at me. I didn't realize that everyone was going to be a follower or what have you, or be DMing and things like that. But I would just be commenting. She says that her theory is very similar to the ideas of David Froning's SU2 conditioning, as well as Ferris Williams' thought process about spin spin being the grand unifier, spin being the extra orthogonal dimension that we have not caught on to. And she visualizes the entire concept of the unification theory as a giant Hopf vibration. Giant Hopf vibration. Does she have an image of it? Hold on. Is this it? Somewhere there is an image of it. So here is Jenny Neilsen, and her presentation on the same exact channel was actually right after Gabriel. Topological space-time torsion. Everybody's using these AI images. I can't deny it. I am too. Topological unified field theory and macroscopic warp geometry. Very, very similar to what we've been discussing. Now, my criticism, if I have them, you know what? I'm going to be harsh. Just because she's a girl, I'm not going easy on her. Number one criticism, it's not really a criticism, it's just that I like her framework as understanding how things relate to one another. I'm not necessarily sure that the universe is a giant Hopf vibration or whatever, but it's a good visualization for understanding the concept. Maybe that's her point. I'm not entirely sure. A really good one, actually. I like it. And so she presents the U1 versus SU2 conditioned fields as like the strings in this shape, in this bubble formation where the lines never cross. Now, let's go to the part I want to listen to, I think, is somewhere around here. Oh, and my criticism. My criticism would only be, if you look at Gabriel's presentation, just focus on the main points. Like, focus on the most strong aspect coming in, the foundational aspect to it, and then build your way up to it. And don't focus on yourself. You know, it's not really about you. You might be the smartest person in the world, but it is whatever. You're almost never going to hear me join an interview or do a presentation where I'm like, well, I'm the smartest dude, and here's what I figured out, and here's what I'm just going to get right on into it. Let the content speak for itself. Have the spirit and the fight of Kobe Bryant. Kobe Bryant won a national championship. Rest in peace, by the way, Kobe. Don't fly helicopters. Never. Kobe Bryant won a national championship, and the next day, he was working out, getting ready for next year. Think about that. Wasn't even celebrating, not patting himself on the back, getting back into the gym, and hitting the weights. That's all. Not meant to be a harsh criticism. Okay, now she makes some really good points in this presentation, and I think they're right about here. So I'm just going to play this out and see where we're at here.
As field lines,
yeah, hold on, right about here.
Potential lines are around it in circles. It's sort of the same dealio with the Hopf vibration. The Hopf vibration, the lines that extend from it, you can think of as field lines. And then the circular parallel circles you can think of as Beltrami potential modes. So it's the potential is perpendicular to the field mode, just like with a regular field line, just like with regular E&M. Anyway, so electromagnetism is the UN fiber, and gravity is sourced from torsion of the object, which is just the Beltrami potential. That's the torsion. It spins around, and it has a slight twist, and the twist actually drags it in a specific direction, which imparts chirality or helicity. It imparts spin. It imparts all the beautiful things we used to get from the Dirac.
So she's taken the Dirac's theory, and she's kind of morphed it and said that we have this idea of spin, and spin is applying this concept that you may have heard of, right-handed versus left-handed chirality. It's like, why does this particle spin one direction or the other? Or why is it flipped upside down versus not flipped upside down? It says, oh, this must be some property of the universe itself. And my guess would be is that we've probably seen this. Like when we look at the, I forget the Russian name, where there's, like if you drop a tennis racket, the tennis racket spins and then flips. You're like, huh, why does it do that? Why doesn't it just keep spinning? I was like, is there some kink twist in space-time that causes these kinds of effects? That's what I believe Jenny is explaining here, or her theory explains, among other things.
So in traditional physics, we have the gauge bundle, and then we talk about particles as if they're excitations of that gauge bundle, but then we don't treat them that way. We glue on this thing called the Dirac bundle, which was sort of a toy model that Dirac was playing with that imparted helicity, spin, the things that we wanted, the things that we needed. And so he took that. Now that thing is a just a regular, there's two kinds of multiplication. There's the regular vector multiplication, and there's the cross product. The Beltrami is the cross product, and Dirac just is the regular product. So the cross product is more accurate. So TOFT replaces the Dirac toy model of the particle. And the reason I call it a toy model isn't because Dirac was like doing something wrong. At the time, he was doing the best thing they knew how, but it didn't put particles on the field. And he showed that means it's on the hot vibration on SU2, like I was talking about, except it's the U1 on SU2. And that U1 meaning the circular symmetry on the sphere. So anyway, so
I want to point out this girl's very obviously knowledgeable. Okay, well, you can, I was muted. I said something stupid anyway. Don't worry about it. She's very obviously knowledgeable about everything related to physics. I'm curious how her background and where she comes from on all of this.
He found that the electromagnetic field was working like a Hopf field, which is what I showed, but I didn't even know about his work, but I just found it. And so that's more verification that you can map regular electromagnetic fields as this crazy bundle. And so it's really just a bundle of field lines, and then it's a bundle of potential lines. And then the potential lines carry torsion, although not very much usually, so you don't usually.
So it's basically a bunch of field lines and then a bunch of potential lines. This should remind you of the Ehrenhoff-Bohm effect, where we see that the potentials are actually the things that are causing the real physical effects. And this should imply that the potentials are a mechanism to space-time manipulation.
See it, but if you can kick it up, you can find the torsion is basically.
That's a good way to put it. A mental model of it. I like her mental model of it. Exactly.
How the theory goes. So the topological coupling is physically evidenced by the 1964 Barger experiment. They pulsed water with an acoustic shock source, and they got a spherical shock shells, 3 of them, and there were 20 modes. And basically, there was no way to predict that, though, and I went through and I couldn't find a way, and I tried more ways than Barger did. So anyway, but if you use my way, if you show the water as coupling to the torsion field on the Beltrami flow, which kind of makes sense because like Beltrami is linked to Navier-Stokes, but the traditional Navier-Stokes equations don't predict this. So
what I liked here, go back a second, was that she drops a real experiment. And she says, this experiment produced these spherical shells into these regimes. And this shows this was something that we couldn't explain. Why is this happening? So I always love when people drop the physics, because at the end of the day, physics is all about explaining what we see experimentally, observationally. Now, I don't want to do her any disrespect, but I'm going to cut her short because I want to flip over to my longer thing around gravity wave amplification. So, guys, check out Jenny Lorraine Neilsen and check out Gabriel. Let me hit up their ats on Twitter, at least, guys. At Gabriel CL Diaz X. If I spelled their names wrong, let me know. And then Jenny Neilsen is Qualia Quanta. So you guys can follow them, check out their stuff, check out their physics. Look at us. We're playing Kingmaker chat. Let's make people famous. Let's do it. We can get more clout for ourselves if we make other people famous. No, I'm just kidding. Okay. The main event. Are you ready? I don't know how I didn't see this a month ago. There's even a comment about can't wait to watch this on Ashton's stream. Found another presentation by Gary Stephenson. Gary Stephenson on Tim Ventura once again. Guys, where did we rank? Where did we rank Gary Stephenson on the Black Project tier list? Whatever it was, probably too low. Probably too low. Probably needs to be upgraded one more rank or two. But now this is the part where on the reverse side, I'm like, you know what? Let's not get Gary Stephenson killed. He's a nice guy. He's like one of my favorite physicists, engineers out there right now. Is he into some Black Project stuff? Indubitably. Indubitably, chat. There's no way you can do a presentation like this here that he's about to show without being dabbling in a little questionably ethical science and physics. But at the same time, oh my goodness, what a resource for knowledge. I could listen to this dude talk all day long, chat. Honestly, he might even get the pass. Even if he voted for Hillary Clinton, chat. Even if he has TDS. I don't know. Maybe he does. Maybe he doesn't. Might have to let this one slide. Okay. We're just going to get into this. I'm excited. For a lot of people, chat.
So what it might hurt.
They watch porn. They watch porn. They watch tentacle porn and bestiality and other degenerate shit, chat. For me, my degenerate shit is watching Gary Stephenson explain how to produce gravitational waves from photons. Forbidden physics, chat. Shit that they ban. You can only get that on the dark web. You don't get this. You don't get this kind of stuff on the normal web. You get it filtered out, chat. You get all the sketchy degenerate physics filtered out from you. So here we go. Get your lube ready, chat. Remember, anywhere, anytime. By the way, why does he have 3 lightning bolts, chat? What's going on here? Are we serious right now? I feel like they're just trolling me directly. 3 lightning bolts? Come on. I'm not trying to go too schizo here, but geez, man.
And the follow-on at Puthoff Shop in Austin. So he actually had a bulk device in mind. So
what did you just say there?
Fact, but is a new way to get it.
Yes, it is. And I can't take credit for the original idea. This came from Giorgio Fontana, who we met during the state conferences that you mentioned. He was also at the working groups for hypergravity working groups, the one at MITRE and the follow-on at Puthoff Shop.
I'm sorry. Did you just say Puthoff's shop? You said it really fast, Gary. You said it kind of fast, but I think I heard Puthoff's shop in Austin. I did hear it. I'm 100% sure. Guys, all roads lead back to Hal Puthoff. Okay? Just, you know what? Put my Pulitzer Prize in the mail. Let my nephew rip it up on the stream. He'll do it in my honor after they take me out. You know what's going to happen. Puthoff's going to send his goons, chat. Giorgio Fontana deserves the original work, the original credit for the idea of converting a photon into a graviton using this mechanism. These mechanisms originate with Giorgio Fontana. He met with Hal Puthoff. He went to the MITRE conference and to Hal Puthoff's shop in Austin, Texas.
In Austin. So he actually had a bulk device in mind. So what I've done here was, it would have been very difficult to build a device he imagined. So what I've done instead is redesigned it so it can be prepared in a thin film manner on a silicon wafer as if it was a transistor array.
I can't tell you how excited I am for this. He's like, hey, he was going to try to do this idea, but it didn't work. And so I turned it into this thin film, and then we also turned it into an array. Why'd we turn it into an array? Any guesses? Any guesses out there? Oh, because it amplifies the power significantly of it. So basically, like, we fixed this shit. It was janky. It wasn't working. Now we got better material science. Now we're going to make this shit a reality. And Gary Stephenson is apparently all in on this, because how many presentations have we watched? Like 3, 4? I mean, Tim Ventura has him on speed dial, apparently. My goodness. Okay. Continue, good sir.
Okay, so let me get into some of the foundational aspects of this, because HFGWs are kind of a niche topic. It is one of those things that some very serious, very rigorous physicists have explored. I think it really got kicked off by the work of Dr. Robert Forward and then Dr. Robert Baker. He did a tremendous amount on this.
Robert Baker wrote one of the DIRDs, chat. I'm going to keep calling you chat. Robert M.L. Baker, Bob Baker, is Gary Stephenson's mentor. Just tell me, which Jason number are you, dude? Which Jason? Did they give you a number? Are you number like 420, number 67, 69? I don't know. I'm just guessing.
For decades. So some pivotal figures were involved with this. You have been involved with this for decades, and you have done remarkable top tier scientific work in this area as well.
Yeah, I give credit to Bob Baker. He was my mentor in this area.
Yeah.
Bob Baker was my mentor in this area. I give credit to Bob Baker. I'm going to regret saying this. Congress should probably talk to this guy. Congress, if you are Congressman Burleson and you're trying to figure out where the UFOs are hiding, well, Hal Puthoff told you the authors of the DIRDs are the Black Project engineers. So you want to know who you should go talk to? You probably should go talk to the authors of those scientific papers that are classified or were classified, including this guy's mentor. Now, unfortunately, a lot of them are dead now. So, wonder who else we could talk to. I wonder if there's anybody out there explaining how we can fucking turn photons into gravitons. Can't find anybody. Nobody anywhere.
It is, I mean, there is incredible legacy. It is within relativity theory. It is supported, to the best of my knowledge, by mainstream physics, right?
It is, although the device we'll be discussing today is more supported by quantum mechanics. But the original work that Bob did was entirely within the realm of general relativity.
So high frequency gravitational waves, again, just as kind of a foundational catch up for folks who might not be familiar or it's been a while. These might be comparable to what LIGO is looking for, except that LIGO is looking for low frequency gravitational waves, if I remember correctly. It's looking for stuff that's
LIGO sensitivity is between 20 hertz and just look up 4,000 hertz now. They're going all the way up to 4,000 hertz. The signals we're talking about are in the gigahertz, microwave range.
Just immediately destroys the LIGO argument. Very first point. LIGO, we're going for the LIGO, Tim Ventura, I'll help you out. LIGO, the reason why LIGO isn't seeing the alien warp drives, because if this is true, if we can make gravitons, then the aliens must have warp drives. Why aren't we seeing them with our LIGO experiment, which is our gravitational wave detector? And the answer is because it's only detecting low frequency gravitational waves from celestial bodies, from neutron stars colliding. It's not searching for the right kind of gravitational waves, from the high frequency gravitational waves that would be produced by aliens. Aliens, chat. When I say aliens, by the way, I use this all-encompassing. Sometimes I'm talking about illegal aliens. Sometimes I'm talking about ET. Sometimes I'm talking about cosmic sentience creatures and plasma creatures, whatever exists. I don't give a fuck. Sometimes I'm talking about jellyfish creatures too. Anyway, continue.
If you were to look at the RF equivalent spectrum versus what I would call very low frequency RF, if you're talking RF range, 20 hertz to 4,000 hertz is extremely low frequency, which is where E6 operates, for instance, in the RF.
So he just said a bunch of technical shit, chat, and I don't even know. I can just tell you he's an expert. I can tell you this dude should be in charge of the UFO UAP learning group. Chat, there he is. 1,000 times more qualified than Avi Loeb. Just said some shit about radars nobody understands and frequencies, but basically admitted, just said The LIGO is low frequency. That's why we're not seeing the warp drives. The moment we turn the LIGO up and we create a high frequency gravitational wave detector, the sky is going to light up with aliens teleporting around. We're going to be like, oh, there's another warp drive over there. Space Force probably already has this, searching for all the aliens coming to try to invade us. Turns out it doesn't seem like it happens very often.
So the reason people should be excited about this is once you get into the gigahertz range, it opens the door for potential communications, potential remote sensing, right? You can do all sorts of things with it, and potentially propulsion applications as well.
Yeah, the thing to keep in mind here is that strain, H strain, which is basically the signal strength, how much you're stretching space-time as a delta x as a function of x, is on the order, goes as frequency squared. So if you change the frequency from 1 hertz to 1 gigahertz, that's not 9 orders of magnitude better signal strength. That's 18 orders of magnitude better signal strength. And then,
whoa, fam. Hello. The strain on space-time increases as frequency squared? Wait a minute. So as you increase your frequency, your strain increases exponentially? So here you go. This is why you're not going to be seeing these effects, except for under specific conditions. And exponential effects, those are my favorite ones. Exponential effects are my favorite ones. So there you go. There's Gary Stephenson explaining the very first issue away.
So if you change the frequency from 1 hertz to 1 gigahertz, that's not 9 orders of magnitude better signal strength. That's 18 orders of magnitude.
18 orders of magnitude by increasing your signal strength, by increasing your frequency. Now you look at Salvatore Pais's patents and you go, whoa, there's a big crossover here. Salvatore Pais was also saying amplification of energy. Look at frequency. Look at the exponential growth in electromagnetism or the magnetic field strength from frequency.
Better signal strength. And then the gravitational wave power goes to the 4th power. So, you're getting watts instead of nanowatts.
So you're going from watts to from nanowatts to watts. That's how big of a jump this is. So the biggest criticism that we've heard from the free energy microchips is they say, oh, well, you're getting these tiny amounts of energy. Scale it up. That's what they say to Sonny White. That's what they say to Garrett Modell. They say, well, you got some picowatt of energy, but that's nothing. Now, enter Gary Stephenson, and he's saying, we can actually scale this up with an array. We can actually use a number of tricks to scale this up.
Picowatts. And so those are the real big gainers. And that's why you want to work with high frequencies, is because of that strain of F squared dependence and that gravitational wave power as F to the 4th power. It's an enormous advantage from a signal strength point of view to go with higher frequencies.
Okay.
Yes, 18 zeros.
So the Josephson junction part of this is really the new aspect. And I have a slide, if it's okay.
Chat, we're making the term Josephson junction a household thing too. I mean, it was already somewhat known, but we've gone from it being an obscure thing that people didn't really know about to now explain how Josephson junctions are basically in every quantum device.
I want to put this up. Let me do a screen share very quickly. And so this is a graphic that you sent me that really describes an HWSC GASER. So can you describe what this is for me, how it works, and
yeah,
what
let me
makes
pull
this
up
so
the same
important?
graphic because yours is kind of small and hard to read. But essentially what we're looking at is trying to force spin-2 transitions in the quantum mechanical realm. And so how do we do that? Well, Fontana conceptualized, because he was a detector expert, that you could motivate a spin-2 transition by coupling an S-wave superconductor to a D-wave superconductor. Typically, a low-temperature superconductor is S-wave. Typically, for at least YBCO, it is a D-wave. Now, I'm talking about D-wave and S-wave. The context I'm using these terms is they're in terms of orbital angular momentum symmetries.
So when you talk about the different types of superconductors, basically we need different kinds of superconductors, and when you look at them, they have different atomic structures. Okay. Now we can potentially make, he's going to mention this, we can make them both potentially out of the same material, and one of them could be like a doped version of it. Doped meaning you mess with the atomic structure to change its properties a little bit. So imagine trying to fit a whole bunch of people in a room, change their orientation, and then doing that and altering it a little bit. And in so, we change the process. The point being, if we set up this specific condition, this basically now turns into a tunnel where the light comes in one way and the gravitational waves come out the other side. Wow.
Looking at orbital angular momentum differences in the distribution inside these materials. Now, the individual gravitons are going to be too weak to measure individually. The trick is to make it a big enough and a powerful enough gravitational wave at a certain frequency that you can actually measure it with a detector of the same design, only flipped around. So now you're getting a graviton in and getting photons out.
So here's another one of the major criticisms as well. Even if this works, how do you measure it? It's so small, the effects, that you can't even detect it from the background. So he says, we are going to get around this by amplifying it using an array and focusing it along a specific frequency. Focusing it along a specific frequency so that when we check that frequency, if we see the strong signal, we know that's coming from this little microchippy thing we made here. Wow. I mean, this is a directly testable thing at a bare minimum.
And so the trick is then to get enough signal strength that you can actually measure it that way. So that's number one. Number two is macroscopic coherence gain. If you can make a number of these junctions and you can separate them by one wavelength, you can get a coherent wavefront. And the coherent wavefront then doesn't linearly scale, it scales as n squared. So we're playing two tricks here. We're going higher frequency to go frequency squared, and then we're also doing a number of emitters to go n squared. So we're pulling out every trick we can to try to boost the signal strength.
So they're increasing the frequency and they're creating their array, which is each separated by exactly one wavelength. So you have to have the arrays set up in such a way where one wavelength hops from one to the next. Chat, I love this shit. This is what I'm going to watch before I go to sleep tonight, if you know what I mean, chat. Oh, my goodness. Felony Physics in full operation right now.
Reciprocity of design, all that is referring to is that you can use the same kind of device flipped around as a detector, which was really Giorgio's specialty, versus an emitter. You can use it in the emitter.
Here you go. You wanted your ghost murmur technology? Here's your ghost murmur technology for you here, right here. Look at this. Emission mode and detection mode. Just think about this. How would I turn this into a detector? Oh, well, I'm going in this way. Photon comes in, gravity wave comes out. Well, on the other side, I'm just going to reverse it. Gravity wave comes in on this side, photon comes out. I sent in the signal on this side. I got the signal out on this side. You've got a phone. You've got a communication system now. Simple as that. Now the question is, how fast do gravitational waves travel? Do they travel instantly? Do they travel at the speed of light? If we needed a way to find our guy, if we needed to find that guy, that pilot in Iran, all we needed was for him to carry one of these devices and for us to have a device somewhere else, and we're going to be able to find him. Boom.
Mode or detector mode. The same device can be biased for emission or can be used passively as a detector. If you bias a Josephson junction, you wind up with the AC Josephson effect, which creates an AC signal, which is beneficial for us because if we have a frequency in mind, we can bias it with a DC voltage, and there's an exact correlation between that DC voltage and the frequency you'll get out of an AC Josephson junction. And so that.
Whoa. There you go, physics nerds. He says, we can apply a DC voltage, direct current, and then we can have it based on the DC voltage we apply. We can get the exact AC frequency out that we want. That sounds like a tunable. I don't know, chat. I'm just a normal healthcare IT basic chungus. I don't know anything about these waves and physics and electrical engineering, but that sounds like a way where we could tune our wavelength to the exact size that we need, especially when I'm building an array where I need every single array to be exactly one wavelength hop from the next one. Damn, I like this. Keep going, sir.
That's the trick we're using here to make a gravitational wave. It shows also the phased array approach on the right. It talks about estimates of power for 6-inch versus 8-inch wafers. I've also done a layout on a 12-inch wafer. These are the 200 millimeter 8-inch wafer is like 140 or so emitters. If you go to a 12-inch wafer, it's more like 300 emitters. And so that's designing for 24 gigahertz. Why 24 gigahertz? It's first of all, it's an amateur band, so it's unregulated. Second of all, it's a happy medium between, we want a large number of emitters. But we also want a frequency that is easy to use. If we start getting above 40 gigahertz or so, the tech becomes very difficult. So it's easier to work with manageable microwave style signals. And so that's why I picked this signal. It was the highest conveniently usable frequency that I could pack a lot of.
So, I mean, this is so well thought out. It's so well thought out that the guy that said we make earthquakes, it's hard to argue with you, sir. I mean, we got dudes out here just spilling the beans on how to make gravitational detectors and emitters and amplify them up to significant scales. And you just have to wonder, like, did the government already figure this out 10 years ago, 20 years ago, 30 years ago, longer? What kind of crazy weapons could we have designed with this technology? Earthquake weapons are honestly kind of trivial at this point. Directed energy weapons, things that just beam energy onto things. It's about to get to be a very scary world, guys.
Emitters onto a wafer. That's why I picked that frequency.
Okay,
and if the quantum efficiency is decent, you can get as many as 83 dB. We don't have a good reading on quantum efficiency. So I saw one of your questions was going to be, what do the skeptics say? Well, the skeptics are going to say, hey, what's the quantum efficiency here? And so I had to compare with similar quantum efficiencies for other Josephson junction detectors. They are used, by the way, JJs are used for nuclear detection, nuclear event gamma ray detection. So
what? Josephson junctions are used for nuclear detonation detection? Of course they are. Of course they are. What was I even thinking? I'm the one saying nuclear weapons are manipulating space-time, and you're saying that we use these Josephson junctions to detect nuclear detonations. Of course we do. Silly me. And the fact that Gary Stephenson is just casually dropping that right here, damn. How does he know this? Very knowledgeable guy. Yahtzee indeed, chat. Yahtzee indeed.
So this is an important precedent, and I used the quantum efficiency from that use to translate it to this use.
Okay, so let me stress how revolutionary this idea is, how timely and how well this fits with our existing technology base.
For challenging environments such as underground mines, that we could use this technology to communicate through the earth to underground facilities and underground mines.
We could use this technology to communicate to underground mines? So this goes straight through solid matter. Straight through solid matter. And my first thought was, well, what about submarines? Because now this is just Hal Puthoff's quantum communication patent from the 90s. Hal Puthoff's quantum communication patent from the 90s specifically calls out the Aharonov-Bohm effect, which was the first half of this live stream. Excuse me. And calls out using this to go through salt water or plasma. Now, Gary Stephenson's presenting it as going through solid matter, which is also crazy, but it's almost like he avoided that specifically. Now, listen to this follow-up. This is crazy. Watch this. If you think I'm the only one thinking that,
we have a lot of government facilities that are underground, and if we want to communicate with them in a stealthy way, we could leverage this technology for something like that.
Okay, and so that would also enable like submarine communications and things like that.
Well, that's why I got interested in this technology at first, was because I was assigned to a redesign of the E6B program. They talk to submarines. They work at very low frequencies, on the order of 70 or 80 hertz. And at that level of frequency, you have to go through a lot of trouble to get a signal from the air to the ground. So we literally would have to fly the aircraft in circles, have a long trailing wire that's like kilometers long. And the submarine would have to have a kilometers long, tail antenna coming out of the back. And that's literally the only way we could talk to subs that were submerged. And so I was thinking there has to be a better way to this. And so that was my initial interest in these high frequency gravitational waves, is what Bob Baker had published in this area. And so I started following his work. And that's ultimately what led him to invite me to Paul Murad's MITRE conference, the first HFGW working group.
No.
Gary Stephenson was on a project where they were trying to figure out how to communicate with submarines more effectively. Chat, live stream's over. Keep Gary safe, chat. I don't want to see any more General McCaslin shit out there. I've had enough. We already have one missing general. We don't need any more missing engineers out there, chat. Just kidding. We're not ending the live stream. You kidding me? This is great.
If I remember correctly, and it has been a while since I dug into this aspect of it, but you can also do remote sensing with this, right? And so like one example of that might be looking for oil deposits underground. Another might be trying to see through walls or something that is just simply too solid for electromagnetic waves to adequately resolve. Right?
Yeah, I would have to part company with Bob Baker on those. Those are very challenging aspects because we would be measuring very small phase shifts in the gravitational wave because it doesn't interact very strongly with matter. And so you have to have a lot of matter to see a little signal. And so matter is essentially almost transparent to gravitational waves. So I wouldn't think it would be useful for remote sensing of matter distribution in the modern sense. However, if there was a metamaterial, if there was some kind of exotic matter present, if there was some kind of negative index matter that would bend the gravitational wave in an unusual way, then I could understand some remote sensing with it. And of course, that's why Hal Puthoff and Eric Davis were interested in it, right?
Of course, that's why Eric Davis and Hal Puthoff are interested in it, right? Honestly, I didn't know they were interested in it, but is it surprising? No, I'm interested in it too. I haven't seen anybody else talking about turning photons into gravitons using a microchip. And I can see the connections to the free energy microchips too. In some ways, this is a little bit superior to that. I want to have a phaser in my phone, chat. I want to have a phaser in my phone that can just zap the bad guys and make the bad guys go away. It's the ultimate Second Amendment. My phone in the future is going to be a free energy device, and it's going to be a phaser that just zaps people away. You point it at the bad people and pull the trigger, and the bad people go away. Petey the pistol. Pew! Oh, I can't wait. I'm going to have a GASER, and it's just going to annihilate any infidel that dares to commit a crime against me. Perfect. I love it. This is going to be a great dystopian future we have. I'm ready for it.
Yeah. Well, and then you could also use this to sense artificially induced gravitational waves, right?
Well, that's exactly why Puthoff was interested. Was he had the charter of trying to find out, how does non-human intelligence craft work? We call that UAP adjacent technology.
Pause, chat. Pause. Oh, well, that's why Hal Puthoff's involved, because we're trying to figure out how the UFOs fly around and communicate, and we call this UAP adjacent technology. Who does? Who calls it that? Name them. Say who's calling this. I'll call it that. It's UFO adjacent technology. Obviously, I knew it the whole time. If you didn't know it, you're a dum-dum. Apparently, we got alien microchips. You know what? I'm down with it. Alien microchips, chat. We've already had disclosure. The alien technology is right here. Honestly, this is alien technology to me. It really is, frankly.
And so this is one candidate. We don't know for sure, but it's one candidate for UAP adjacent technology. The thought being that
we don't know for sure, chat. It could be anything. It could be this thing that Hal Puthoff and Eric Davis and Gary Stephenson and Giorgio Fontana went to the MITRE conference and did all this. It could be anything. Could be this very specific thing, highly specific thing. Or it could just be something else. Could be anything. Holy shit, chat. Where do I sign up for this?
In order to communicate through a warp bubble or a plasma bubble, you're not going
to... Chat. To communicate through a warp bubble or a plasma bubble, you need something like this, chat. Boy, oh boy.
to be able to use regular RF frequencies to penetrate those kinds of environments. Those are very challenging environments. However, you could use high-frequency gravitational wave communication to penetrate those environments, which might mean, instead of working in some other dimension or something, if they're communicating in our dimension, they may be able to be communicating using gravitational waves through these very challenging kinds of craft structures.
Okay. So to bring that back to human technology then.
Bro, this interview just went off the rails, and I'm here for every moment of it. I didn't realize you could just be like, hey, Gary, so how does this relate to alien technology? And he would just pop off like this. Most of these people are shy about it. Gary's like, nah, we got this alien technology. This is alien tech. This is some shit we got from aliens. We figured it out. Now we're just doing it. We're building it. It's like, geez, could you be more casual about this? You're kind of you're dropping all the secrets here at once on me.
That reminds me of subspace communications from Star Trek.
It would be.
This is like Jujutsu Kaisen, man. He's coming out. He's like, can you please fight more subtly? You're being a little too brash right here with the way you're exposing anti-gravity a little too just bluntly and forcefully for people. This is why I love Gary Stephenson, by the way, because the way he answers that is just, you can tell he's just being perfectly honest. He's like, not even trying to beat around the bush. He's like, yeah, it's just alien technology. We figured out from the UFOs. We've been working on it, building it. I do it all the time. It's just like, just act like you've been there before, bro. It's like, oh, you don't work on the alien technology? You didn't get that surgery yet. Sorry. The only people that get to work on this technology is me and Bruce Willis. You ever see Armageddon? Yeah, exactly.
Subspace, I mean, it's not faster than light. Faster than light, you would need quantum entanglement. So that's instantaneous. We're talking about this doesn't invoke quantum entanglement. This is simply a way to get through matter, a way to get through plasmas, a way to get through warp bubbles, because it does not interact strongly with those things.
Okay.
We don't even need quantum entanglement. Quantum entanglement. We don't even need that shit. That's old. That's old shit. We got just abilities to go through a solid matter, plasma bubbles, and warp drives. Can just use straight up normal light speed gravitational waves. Don't even need the entanglement. Look at that. Way around it. People are like, we can't figure out the UFO technology. Here's Gary Stephenson like, we figured out the UFO technology, and turns out we don't even need entanglement. We can just go straight through solid matter just using these gravity waves. We just convert light into gravity waves. All the dum-dums out there just aren't paying attention to Giorgio Fontana, apparently.
Okay, I see what you mean. And again, some of the key advantages here, and I still have the graphic up on the screen, are, I mean, this uses conventional chip fabrication technologies, right? So
and test technologies and probing technology. So you would use cryoprobes.
Oh, yeah. And by the way, Gary Stephenson also just happens to be like some crazy expert on lithography and nano fabrication. Like, in addition to all this crazy, what do you call it? Signals, kind of intelligence type stuff.
The form factor makes in the experiment itself. Because a regular probe, I mean, if you use an SMA connector, for instance, which is typical in microwave, that's such an enormous heat sink, you could never keep anything down to 4 or 7 Kelvin. So you really have to be careful with how you probe these devices, that you're not leaking a lot of heat in.
Yeah, no, it is so exciting. Another place that my mind goes before I take this down is having these sensors, right? I mean, you've got arrays of sensors, which I think is also potentially helpful for filtering out noise. Being able to use these sensors for things like Dr. Sonny White's Casimir effect research, or his warp drive research, or reactionless drive research that's been going on for decades. There's no great measurement tools for that, right?
That's right. So if you actually could get a link between a transmitter and receiver, then you could put different metamaterials. I think about all the metamaterial research that's been speculated about.
But they're saying you can use this to detect the gravity waves too. Of course you can. So if Sonny White and his microchip is manipulating space-time, producing free energy from space-time, this can also detect that. Of course, the government's already got this. We're like reverse engineering technology the government's already had. In fact, this probably is just government technology. And how does it get out? Well, these guys work behind the scenes, and then it's like a catch-22. You can't admit that technology was stolen from them, because then you're admitting that you have it and you're not supposed to have it. Pretty crazy. Yeah, and you can change it back into light, which gives you signaling and communication capability. The same signal that got converted to a graviton can come out back as a signal, the same message that came in. Just a game of telephone now. I'm going to skip ahead a little bit here.
Quantum effects to macroscopic levels. Impact the gravitational pairs of superconductors that are separated by a very, very thin insulating layer. So it's like a transistor, except it's superconducting. And the insulating layer is such that it only allows electrons to tunnel through it. So it's a tunneling type of transistor, and only coherent electron pairs can tunnel through it. So because it's superconducting. So this allows the device to magnify quantum effects to macroscopic levels.
Okay.
And boom. This allows the device to amplify these effects to macroscopic levels. This feels like the missing link from going from, yes, this is real, but it's too small to be measurable and too small to make a difference and too small to charge anything, to now scaling this up to now we can produce a gravity wave where you can feel the pushing effect, where you can feel the work being done. And this can also then be used to test other people's gravity wave production devices to see if they're working, including stuff that Sonny White has been working on, where he's been working on both warp drives and he's been working on his free energy microchip.
So the term, and again, folks read this in the description, the term we've used is GASER, which is like a laser for gravitational waves. Now, does the laser analogy fully hold when you get into gravity, or where does this analogy?
To some extent. So laser stands for light amplification, stimulated emission of radiation. So what's the same is we're stimulating an emission of radiation. So the SER part is the same. Now we're stimulating the radiation of gravitons versus photons. So that's the difference between a laser and a GASER. Where the analogy somewhat breaks down is when you have a laser, you're sending light in, and then it starts getting amplified. In this particular case, we're stimulating it by biasing the Josephson junction to create the AC effect with spin 2. So there's no amplification per se. What we're really doing is we're just generating gravitons using this bias.
So it's not a same kind of amplification as a laser. In a laser amplification, you send a beam of light in there and it hits the medium of gas, and then it causes all of those particles to be excited. And then when population inversion occurs, when most of the population has been excited, then you get this stimulated emission. Now, in this situation, we're saying that this isn't exactly how it's working. Now, instead, we're just building an array of all these things that is converting light into gravitons, and we're having them amplify from their shared effects, geometrically aligned. So slightly different, but same ultimate idea and concept of what we're trying to accomplish. A larger amplified effect.
Yes, and so that's where the analogy breaks down, is it's not really truly an amplification of gravitons. It's a generation of them.
Okay, but
so
like
A and GASER.
like a laser, though, a laser uses coherence. That is a key
They're both coherent sources. Yes, that's right.
Yeah, and so that coherent, I wanted to focus in on that because many tiny quantum systems acting together produce an effect that a single system can't produce on its own, right?
Well, that's right, and that's the whole point of going to the higher frequencies. That's the whole point of coherent arrays of these things. Essentially, I grew up in the microwave realm of phased array antennas, so I just applied that same phased array thinking to these gravitational emitters.
Now,
so he's an expert on phased array systems as well. Gary Stephenson is. Yeah. Guaranteed he's familiar with the work of Tom Beard and scalar physics, which I saw a lot of people mentioning in the chat. Definitely there's some overlap, but it's not the same.
Now, I should ask, in practice, how difficult would it be to build a prototype sender-receiver pair for these? I mean, do you have any guesstimates on what the cost would be? And what would your preferred first test be for this?
Well, you want to see if you can really couple, because you can say it's emitting, but until you measure the emission, there's no way of telling. So you really do have to have a pair to start out with. And so that requires at least 2 devices. And I had some initial estimates from a microelectronics lab that does specialty arrays, specialty wafers, UC Davis. They have a microelectronics lab there. But that was for different materials than what we're talking about now, because they weren't scoping YBCO. And last time I talked to Fontana, he really stressed for the type 2 for the D wave. It's not type 2 and type 1. That's where I got confused. It's S wave and D wave. And so for a D wave, you really have to have the YBCO or BSCCO. You have to have some cuprate.
Okay, how much is it going to cost?
Rate like that. The cuprates are the ones that have these distributions, this quadrupole distribution, and that's what you need for a spin 2 transition. That's what you need for a gravitational wave made of gravitons. And so you really do need a device with YBCO. YBCO is very difficult, one of the most difficult materials in the world to work with. So these would be, very expensive devices, probably on the order. I mean, if you're doing custom fabrications of YBCO, we're probably talking on the order of hundreds of thousands of dollars. If you're
hundreds of thousands of dollars. Free energy ain't cheap, chat. Turns out we all thought free energy was going to be free. Turns out it's expensive as shit, chat. Now you know why Sonny White raised $12 million for his microchip. Because you have to fabricate a bunch. You got to test it. You got to have proven results. And then you got to do mass fabrication and commercialize it. That can easily burn through millions of dollars. Easily. But when we get there, theoretically, you got $1 trillion company.
An angel investor, it's not a lot of money. It's a lot of money to me.
Okay, let's skip ahead a little bit. I only want to look at 2 more parts. Here we go. Somewhere around here. I don't remember where it was.
Just gravitational waves, so that we're not only viewing them from the paradigm of astrophysical events, but also as signals.
That's where the disconnect is right now, I think, with the astronomers and the GR experts, is they're used to this enormously small coupling between gravitation and matter. But that coupling is quite different when you start looking at the higher frequencies. It's quite dramatically different. So yes, there's 47 orders of magnitude in the mud where the coupling is, if you just look at it that way. But if you start multiplying by 18 orders of magnitude for using a higher frequency, and then probably another 10 orders of magnitude if you can do it on a phased array, suddenly you got the problem within 20 orders of magnitude or so, which as a satellite comm person, former satellite comm person, doesn't scare me anymore, because 200 dB of loss is not a big thing for satellite people. It's like, that's every day.
Wow. Wowzers. So there he is. He's saying that if we do 2 concepts, one, go to ultra high frequencies, that increases our output by 18 orders of magnitude. The other option, phased array, that's another 10 orders of magnitude on top of that. So he's saying now we've solved, or we are trying to solve, the problem that all the critics say there's not enough energy coming out of this. The effects are too small. If this works, it's game over for all the classic physicists, all the classic physics debunkers that are out there. Their worldview would be shattered by this.
Yeah, and this seems like it also answers one of the major criticisms skeptics have had in looking at propulsion aspects of this. They're saying, okay, even if there's an effect, it may be weak. And when you're looking at the communications aspects, that is very normal. We just compensate for it.
Yeah. So those kinds of numbers are fine for comm. For propulsion, I don't know that you would get a lot of oomph out of that. You would have to use a much higher power. And then you have to find a way to rectify it, find a way, or multiplex different frequencies. There's this trick in Fourier transforms where you can get a square wave out of adding frequency 1 times 3 times 5, and putting together those different frequencies gives you a different overall waveform.
Did he just say square wave, chat? Did I just hear Gary Stephenson say square wave? Where we found that was potentially the secret, because the relaxation and the excitation waves don't perfectly match.
You can use those combinations of different high-frequency gravity waves potentially to have a waveform-shaped wavefront that can give you field propulsion, potentially. Now, how strong?
So you could use this for field propulsion, but it's not going to be very powerful. So this would maybe be a very, very, very weak propulsion effect. You're not going to use these microchips to make a warp drive, except for on a very, very, very tiny scale. This is why you need the plasma. Plasma is producing the extremely powerful electromagnetic effects we need on the large scale to manipulate actual space-time macroscopically. But these devices will still have more practical use for us than plasma balls will teleporting us around. These devices will allow us to communicate through solid matter. In some cases, communicate at the speed of light or faster than the speed of light, no lag or minimum lag. And these devices will be able to allow us to have free energy, at least on our phones. Now, powering our whole houses, maybe not, but we'll get there.
Is that's not just an engineering problem, that's a difficult physics problem too.
Gary, if it's okay, I'd like to share the quantum high-frequency gravitational wave blueprint that you sent me as well.
Oh, okay. And you look at the semi-classical, it doesn't really have this N2 scaling that the quantum effect has, because the quantum factor allows these quantum emitters to be coherent. There's no notion of coherence in general relativity.
So right there, this is the huge difference. There's no element of coherence in general relativity. This is the gap between the classical and the quantum limit. This is why I can already feel Sabine Hossenfelder seething, preparing her next counter-signaling physics video, obsessed with us, chat, living rent-free. This is why these devices can amplify beyond what quantum Sabine and the classic physicists believe is possible. The semi-classical theory does not have the coherence gain and why the array amplifies this effect. So ultimately, at the end of the day, I guess we'll just have to see it. I mean, if we build this and it does it and it works and it amplifies the effect and the effect is stronger than the classic theory predicts, then we'll know. We'll know it's true. I'll go ahead, chat. I'm going to go ahead and bet all my money that exists in this world that this is true and that this effect is real and that there really is an ether. And why am I going to do that? Because I've just watched a plane get teleported out of the sky, and this is definitely the same physics they're using. Definitely. So the aliens didn't download the information into my brain. Just straight up classic old school investigative journalism at play right here.
So that's called the coherent gain. And it's pointing out that when you start using the quantum approach versus the semi-classical approach, you actually wind up with depending upon n, quite a drastically different answer. So that's the first thing I would
drastically different answer
point out with these slides.
And then if it's okay, let me go down to, I want to go down to the physical mechanism, the HTSC GASER.
Yeah, let's go look at that next, because that points out the differences in material type.
Okay, I'm going to skip over the material type thing because he basically says that we might be able to produce both sides of this with the same material, make this a lot easier. The one they're doing right here is using two completely different materials, but this requires two different temperatures, which is now another engineering challenge. Still works, but you can imagine from a practical perspective, it'd be nicer if we could just cool this whole thing to one temperature. So let's skip ahead of that and go on to like about here.
Emitters.
Okay, so
I thought this was interesting.
About frequency selection. I don't want to get too in depth with this, especially since I know you were going to be.
This is the most detailed we're going to get into the frequency selection and picking the frequency and finding the right frequency. So pay attention.
Done this in the future, and I'm going to put a link in the show notes. I'm going to put links to all of our information.
The nutshell version of this is that you'll see that frequency of the Josephson junction, AC Josephson junction effect. It goes according to that exact frequency. So if you put in a certain voltage, you get a certain frequency. It's 483 terahertz divided by voltage, and so these are very small bias voltages, right? That if you want to get down to the gigahertz, you're in the nano or millivolts in order to do that. So, but that's the fundamental frequency of AC Josephson effect. So that's all that's being described here. So for instance, for 24 gigahertz, you only need 49.7 microvolts of operating voltage across these little emitters.
Okay, so low power.
Low
power.
These are low
so
power.
Many.
So these are very low energy devices, which we kind of already knew in terms of how much energy it takes to run these things.
Amazing aspects of this. So let me go down to phased array geometry. This is, I mean, again, you've gone through this whole thing. You're working up a complete.
Yeah. So these layouts are very poor. The AI got confused.
This is the part that I think Jenny Neilsen would appreciate the most, the geometry. Because this geometry is going to be the same underlying geometry as the structure of her theory, in my opinion. We'll see.
Just here. If you want to look at the real layouts, you can look at my briefing separately. But the idea is to orient these emitters and receivers so that there's one wavelength separating each of them. There's the bigger wafer you have, the more emitters. You have to use the one full wavelength spacing. And then the pad size for the emitter shouldn't be any more than a quarter wavelength, because you start getting out of phase. So there's a certain limit to the size of each emitter pad, as we do in microwaves. And so that's the idea here. And so even though these particular layouts are notional, you can look at my briefing for the real layouts.
Okay. And then let me see, beam focusing. And again,
So Fontana was looking at this and came to the same conclusion. You can't create a lens out of matter that is going to change the phase of gravitational waves, because the interaction is so weak. What you can do is shape the emitter so that it's just a delta T that's causing them all to come into focus. It's creating a delta T because you have shaped all the emitters so that the delays are all correct to all come together. So like a spheroid section, or you can do it with a flat one and then just do time delays into each emitter, which is what we do with phased array antennas on aircraft.
So right there, he's talking about building in a time varying condition. He's talking about changing the delta T and taking advantage of the obsiverse. Chat, we're all living in the obsiverse. Everyone's going to be calling it that. Eric Weinstein called it the obsiverse. Taking effect. This right here immediately made me think about the plasma orbs. They must be using the exact same type of effect on a macroscopic level.
Okay. So we can still create a focused array, but you're doing it with time delays versus with a big curve.
Well, it's interesting looking at the physical curve, right? That reminds me of something I was reading about. So when you talked about the phased array delay line,
we can do it with a time delay instead of a physical curve. So you would say, Ashton, how can you just use 3 orbs to make a wormhole? Don't you have to make like a full bubble? And this is almost, I think this is what Gary Stephenson's saying, is that no, we don't need that. We can actually simplify it using the math and quantum mechanics. We don't need to have a full spherical bubble around this. We can just set up our array in an intelligent way. Wow.
What immediately came to mind just a few moments ago was like a Fresnel lens.
Fresnel
But,
lens,
yeah.
Okay, let's get that a little bit.
Okay. Yeah.
You can separate them by quite a bit. So you separate them, and then you'll have the R squared or the D squared distance fall off because you're changing the radius here. But nevertheless.
Okay, I think we got that part. Let's go to the end. I think you asked some questions. Oh, here we go. Here's the next steps.
So you measured with your wave as well as the S wave, in which case the whole thing could be cooled, in a month. Yeah, I mean, the immediate term is build this and test it in a lab. There are other fundamental breakthroughs that describe, and we talked about this a little bit, that YBCO might be able to be used for the D wave as well as the S wave, in which case the whole thing could be cooled, at a much higher temperature, maybe not 70, but maybe like 40 or 50 Kelvin.
Why? By the way, guys, why does this feel like we're like watching some Nobel Prize winning thing like years in advance? Why does it feel like that? Like there's nothing like this out there, and it feels like such an obvious thing based on the research of Fontana. It's like, we're trying to get a gravitational effect. There should be some coupling. And what Gary Stephenson was saying earlier is that perhaps the reason why we're not seeing this coupling is because we need to increase the frequency. We increase the frequency, and the effect of this coupling, electromagnetic coupling to gravity, becomes much stronger. It becomes much stronger with an increase of frequency.
It depends upon what the doping level is. And then if you have a link budget that you've successfully characterized, you can use this for basically gravitomagnetics testing to test metamaterials. If you have a theory about materials shaping a wavefront or changing gravitational aspects, you can test it. You actually have a test bed now. So that would be very beneficial.
Amazing. So Gary, let me stop sharing on.
Is that it? I thought that's not like a whole lot of details. Like, well, we could just build this and test this. Like, okay, what's the next step? You know what? Keep Gary safe, chat. We don't need to. I don't have any more questions. I don't need to know anything more about it. Just keep doing what you're doing, bro. Keep doing what you're doing. I can't wait for the next presentation on the Josephson Junction gravitational wave. I'm calling it Amplifier, even though technically it's a GASER, chat. Okay, our moment of Zen tonight. Very special moment of Zen tonight. Where's my guy? Hold on. Let me get it ready. Oh, boy. This is dramatic. Let me see what we got. Oh, you know what? There was one more clip I was going to play. before we go to that, I want to play this clip of James Woodward explaining the warp drive. Hopefully, if you've learned something tonight, this will make more sense to you than it did at the beginning of the live stream. So here you go.
People in the 0 point field all cranked up because, oh, the ether, the 0 point field, and so on. And what he meant was space-time is the gravitational field. It is not something else. Gravity is not something in space-time. It is space-time.
Woo! My goat! Gravity is not something in space-time. It is space-time. 0 point energy is space-time. Do you get it? You say, Ashton, well, if all this energy is keeping up all the atoms everywhere, then we must be in some kind of ocean of energy. Yeah, it's called space-time. It's called everything you're in all the time. Exactly. That's what people need to get through their head. Gravity isn't some effect that's being exuded. Gravity is space-time being morphed, being bent, being shapen.
So when you manipulate gravity, you are manipulating space-time. That's why when you make a wormhole, when you get a Jupiter mass of negative rest mass matter in a sphere, say 10 meters in diameter or thereabouts, you can create a wormhole. Okay?
When you manipulate gravity, you are manipulating space-time. Thank you, Luara. Thank you. When you manipulate gravity, you're manipulating space-time. That's why I say we have space-time manipulation technology, A, because it's true, and B, because it's also technically accurate.
The problem is, where do you get a Jupiter mass of negative rest mass matter? And the answer to that question, if you read chapters 7, 8, and 9.
Chapters 7, 8, and 9? Like Salvatore Pais's equations 7, 8, and 9? He says, everybody agrees if I have the mass energy of Jupiter, I can create a wormhole. But we need negative energy. Where are we going to get the negative energy from, chat? Remember, our balloon is already squished. We need to unsquish our balloon, and when we unsquish it, we get the negative energy. So let's listen to what Woodward has to say.
It's all around us. You, indeed, contain within you an utterly enormous amount of negative rest mass matter. It's the bare mass of all of the elementary particles that make you up.
Everywhere around us. It's the bare mass of all the particles that make up you. It turns out the energy we need is all around us everywhere. He's saying the exact same thing.
The only reason why it isn't exposed is because of the gravitational action of everything else in the universe on you. And if you can find a way to screen that interaction, you reveal the bare mass.
He says all the other stuff, everything is connected, and it's all keeping everything stable. If you can screen that away, boom, negative energy. If you can screen the gravity away, screen that pushing force, stop the balloon from being pushed down, boom, the balloon will expand automatically because the balloon wants to expand. It's just being prevented from doing so all the time.
And now you've got your Jupiter mass and negative rest mass matter. Okay, and that's a real tall order. But if the experiences that you and your compatriots are having and all that are true, it means that someone is, or something, has figured out how to do this. Okay, but within the physics that is we know today, that's, as far as I can see, the only hope of making either warp drives or wormholes. Okay?
Beautiful.
Wow. Beautiful chat. Beautiful. Now you see this has been out there waiting to be discovered for a long, long time. And it's been an us problem. It's been a psychology problem. All that needed to happen was for us to wake up and realize these guys aren't full of shit. We just needed the proof and evidence that would make it undeniable. That's why I asked Pat Vetted on Saturday. Check out the podcast, guys. I asked him, well, if those videos ended up being true, the MH370 videos, you would agree we must have this crazy technology. And he said, yeah, if those got proven real, he would, because there it is. This is why I say all this stuff is real. I realized those videos were real and then just followed the science and boom, there it is. It's all just here. And turns out it's all the government contractors, government engineers, and they're bragging about it on podcasts because nobody believes it anyway. You just have to watch and learn and see for yourself. Guys, we have a live. I think this is live. Sabine Hossenfelder has been watching the live stream. We've got a live reenactment of Sabine Hossenfelder watching the live stream. MH370X is represented by this bison here, just chilling. He's enjoying, look at it, he's loving life, rolling around, enjoying the 0-point energy. And look at these douchebags back here, pissing him off. Look at him. Oh, shit. They were talking shit. This is what happens when you talk shit about 0-point energy right here. Let's go full screen. Oh, see? The 4 orbs curse is coming. The 4 orbs curse is coming for you, Sabine. Look at her run. Look at her run, chat. You can't escape the 4 orbs curse. It will find you. We're messing around with that tree. She thought she could hide. This is Elon retweeting. Oh, Elon reposts. GG's. Woo! The 4 orbs curse comes for everyone, chat. Remember that, Quantum Sabine. Remember it. Rest in peace. I hope she recovers quickly from that mogging the other day. Let's go to the super chats, guys. Thank you for hanging out tonight. Thank you for appreciating the science stream. I know these are the most boring ones for my dum-dums out there. Mick Leonard says, I wish I could teleport the libs. Chat, we're not going to teleport. We're not going to waste teleportation technology on them. They don't even believe in science anyway. Why would we waste teleportation technology on them? No, we're going to shoot them to the moon in a classic doomsday rocket that will just possibly blow up from anything touching it randomly. We're going to shoot them up in a conventional rocket that will make them feel comfortable. We're going to send them to the moon, and we're going to put them on the moon base. And they'll have all their basic needs, food, video games, anime. It's going to be very humane and very legal. Everything about it. They're going to love it, chat. They're going to love it the most. Thank you, Mick Leonard, for that. I appreciate you. J Beach loves ZPE says, what's the difference between a hippo and a Zippo? One's very healthy and one's a little lighter. Oh, we got the Laffy Taffy dad jokes. Thank you very much, J Beach. I appreciate you. XLX Squee says, check out his UHT Yuan theory, guys. Says, yes, sir, we're out here trolling the government agencies for fusion. You should see the feed, LMAO, at Gov Nuclear at Energy. I've been shoving my reactor blueprints down their throats on their feeds, pitching to the goats themselves. Hal Pudov. Congratulations, sir. Keep it up. Make sure you are going in for your health, your doctor's appointments and checks. Make sure you're not going to any empty elevator shafts. Be very safe. Keep everyone very safe who we've been revealing and talking about here tonight. Brian Pemble, shout out to you. Thank you very much for that super chat. Says, great work, Ashton. Cavitation. Think about cavitation. What is cavitation? Cavitation is the bubble walls collapsing. This is why Julian Schwinger realized this must be a 0-point energy effect in sonoluminescence. Look at what happens with the orbs converging. We're seeing the boundary conditions rapidly changing. It's actually all about the boundary conditions changing. The 0-point energy walls, the walls are changing the 0-point energy modes, just like the Casimir effect. Dynamic Casimir effect and boundary conditions. Once again, that's tonight's felony physics topic. And then lastly, Chaotic Good says, not me trying to hire Ashton lookalike that got fired from Chili's to be my pool boy. Oh, yikes, chat. When Piers Morgan goes away, Mr. Four Orbs comes out to play. Your new pool boy, Mr. Four Orbs. Look, can you imagine Four Orbs lookalikes in the future playing pool boy to Desperate Housewives? Chat, I could see it. I could see it becoming a reality. Guys, remember, space-time is not empty. And also, anytime, anywhere, the VPU2 is watching you and maybe teleporting you with some lightning bolts. Have a good night, MH370X. I love you guys. Peace out. Later.
In the fields where the skies are wide, talking about a journey through the cosmic ride. Einstein and Thorne, they set the stage for a trip through time across the space age. Wormholes connect distant points in space, traversable paths to a far-off place. No black holes pull, no crushing weight, just a cosmic tunnel to a distant gate.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow. We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow.
Exotic matter, negative energy's the key to stabilize the wormhole for you and me. Quantum vacuum squeezed so tight, creating conditions for this wondrous flight. Static fields and lasers in the lab they play, generating forces in a new kind of way. Gravitational squeezing, Casimir's force, negative zones we need to stay the course.
Talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Bowling 777 through a wormhole flow.
Thin shell formalism plates so fine, spherical geometry we realign. Energy conditions that we must defy. For a stable wormhole, let's give it a try. Forces balancing the plate, creating the throat, opening gates from Earth to the stars in a single bound. A shortcut through space profound. Engineers and dreamers hold the key to future worlds and what we could be. With science in hand, we forge ahead through the cosmic paths that we now tread.
We're talking wormholes, stargates, negative energy, travel through the cosmos, it's our destiny. MH370, where did it go? Boeing 777 through a wormhole flow.
From the fields to the stars, we break the chains. Understanding the universe, we make the gains. Lil Hula Crunk shines, bringing truth to light. Through his music, we'll explore the night. With wormholes and stargates, our path is clear. Exploring the cosmos, our future's here.